Hello friends, myself Rajendra Mahajan presenting my video on characteristic equation and eigenvalues of matrix. It gives me immense pleasure to share you that this is my video number 1000. This is possible only because of your continuous support and response to my channel, and I expect the same in future also. Thank you so much for your response. Let us try to solve the problem. Find characteristic equation and eigenvalues of matrix A is 3, 10, 5, second row -2, -3, -4, and third row 3, 5, 7. Please watch the video up to end for clear understanding or better understanding of the problem. As I have discussed in the last problem also, the characteristic equation is given by determinant of A minus lambda I is equals to 0, where lambda is any non-zero scalar quantity and I is the identity matrix of the same order as the order of A. Or we can use the shortcut method to find this characteristic equation. It is nothing but lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equals to 0. Terms alternately positive, negative. Where specific meaning for the terms, where s1 is the sum of the principal diagonal elements, s2 is the sum of the minors of the principal diagonal elements, and the last one is the determinant of A. Therefore, to obtain this characteristic equation, we try to obtain all these quantities. The first one is the value of S1. Therefore, the value of S1 is sum of the principal diagonal element, means diagonal from left to right. That elements are 3, second diagonal element is -3, and third diagonal element is 7. Therefore, 3 minus 3 get cancelled. We get the value as 7 for S1. Then S2 is the sum of the minors of that principal diagonal element. Therefore, minor of the first element, neglecting the first row and first column, we get a determinant of -3, -4, 5, 7. Then minor of the second diagonal element -3. Neglecting this second row and second column, we have the elements in determinant 3, 5 and 3, 7. Then the minor of the third diagonal element 7, neglect that row and column containing it. Remaining elements are 3, 10, -2, -3. I take a determinant of that. 3, 10, -2 and -3. And then evaluating this determinant, we get -3 into 7, -21, minus minus it becomes plus, 5 4s are 20, plus again 3 7s are 21, minus 15, 5 3s are, then plus -9 and minus it becomes plus, 10 2s are 20, and therefore simplifying the terms we get 20 minus 21 as -1, 21 minus 15 we get 6, and 20 minus 9 we get 11. Therefore, 11 plus 6 we get 17 minus 1, the value as 16. The value of S2 as 16. We find determinant of A. Determinant of the elements of the matrix are 3, 10, 5, minus 2, minus 3, minus 4, 3, 5 and 7. And therefore, evaluating this third order determinant, as usual we are performing that calculation. Therefore, firstly, neglecting first and first column, determinant of the remaining elements minus 3, minus 4, 5, 7. I will show the calculation in detail. Then minus 10, second term with minus sign, neglecting that row and second column, we get determinant of minus 2, minus 4, 3, 7 and plus 5, neglecting first row and third column, determinant of minus 2, minus 3 and 3, 5. Simplifying it, 3 into 7 3s are minus 21, minus minus plus, 5 4s are 20, minus 10, minus 14, minus and minus plus 12, 5, 5 2s are 10, minus 10 and minus minus plus 3 3s are 9. And therefore simplifying it, 3 into minus 1, minus 10 into minus 2 and plus 5 into minus 1. And therefore simplifying it, further simplification, minus 3 plus 20 and minus 5, 20 minus 8, we get the value as 12. Then substituting the values of S1, S2 and determinant of A in equation 1, we call this as equation 1, suppose. And therefore we have lambda cube minus S1 lambda square. The value of S1 is how much? It is 7. Therefore 7 lambda square plus S2 lambda, the value of S2 is 16 lambda and minus determinant of A, determinant value is 12. Equation number 2. Whatever this equation in terms of lambda is called as the characteristic equation. Answer for the first question. Then after obtaining this characteristic equation, we have to obtain the eigenvalues or the characteristic roots by solving it for lambda. Therefore, as it is cubic equation, we have to solve it by synthetic division technique. Therefore, writing the coefficients in decreasing order from left to right, it is 1, minus 7, 16 and minus 12. And then by trial and error technique we check whether plus 1 is the root, minus 1 is the root. For plus 1, if the sum of the coefficient is 0, 17 minus 7 we get 10, 10 minus 12 we get minus 2. Sum is not 0, means 1 is not the root. Then alternate sum of the even and sum of the odd. Therefore 1 plus 16 is 17 and minus 7 and minus 12 again not equal. Means here 1 and minus 1 are not the roots. Then we have to check whether plus 2 minus 2 plus 3 minus 3 like this. Therefore I will go for plus 2 first, as 2 is the factor for that 12. Taking the first as it is 1, product of 1 into 2 we get 2 here. Sum is minus 5, minus 5 into 2 we get minus 10. Sum of this 2 as 6 and 6 to the 12. Therefore last sum is 0, means the first value of lambda is 2. And if we remove the one factor from that cubic equation, the remaining factor is of order 2, therefore it is lambda square minus 5 lambda plus 6 is equals to 0. Then we have to obtain the factors of 6 such that product must be 6 and sum must be minus 5. Therefore, we consider the factors as lambda minus 3 and lambda minus 2. Here the minus 3 into minus 2 we get plus 6, and the sum of that minus 3 and minus 2 is minus 5. Means these are the correct factors. And therefore equating each to 0, we get lambda is equals to 2 and lambda is equals to 3. And therefore the eigenvalues are lambda is equals to 2, again 2, and then 3. These are the eigenvalues. Answer for the second. Then whether it is correct or wrong, that we check with the property of eigenvalues. The first property is that sum of the eigenvalues. Here the sum is 2 plus 3, 4 plus 3, 7. That must be equals to sum of the principal diagonal elements. Yes, what are that principal diagonal elements? Diagonal from left to right. If we see the problem, diagonal elements are 3, minus 3 and 7. Three minus 3 and 7. 3 get cancelled, we get that value as 7. First property is satisfied. Product of these eigenvalues, that is 2 into 2 into 3. 4 3 is 12. And if it is equals to the value of determinant of A, what is the value of determinant of A we obtain? It is 12. And therefore we get 12 is equals to 12, means second property is also true. And as these properties are true, for that obtain characteristic equation, whatever the equation and eigenvalues we have obtained are a correct one. And if you know that it is correct one, you know that you will get full marks. Means you can fix your marks also by checking this type of properties. Please like my video, share it, as well as subscribe to my channel, and to receive the notification of such type of new videos, please press the bell icon. Thank you. Thanks for watching.